some of the comments is, oh, this is nothing new, blah, 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 blah. And I said, well, it is. Okay, I'm here with Tim Lennon, who's kindly going to give me some time to do a bit of a Q&A on his pretty cool Predator Raptor battery, which we made a video on. And I'll leave a link at the end of this video to the full interview we did with that about that battery. And in the comments of that battery video, there was a heap of comments, just questions. I thought, yeah, a lot of these are just simple questions that you probably could answer quickly and easily, and would just help explain how it all works. And obviously, you're going to get your fair share of negative comments who just automatically poo-poo it and just say this is rubbish, blah, 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 blah. But this is really for those who want to better understand what this battery is and what it's capable of. So I'm going to hand it over to you, Tim Lennon from R&J Batteries. If you can just give us a little rundown of what the battery is and what it can do.
So as we talked about, I guess, in the video, it's a lithium iron phosphate battery, and we chose that chemistry because it's safe, stable, non-combustible, so it doesn't suffer from any of the thermal runaway or other issues that some other, I guess, high-performance lithium batteries can suffer from. We developed it to, I guess, answer and solve a whole lot of challenges that we've seen in the past with other lithium batteries. We've been in business for 30 years. It's actually our 30th year. Quick plug, R&J Batteries, family-owned business. This is our 30th year. Business actually started towards the end of the year, I think, interestingly, but we're celebrating it for the whole year. The same guy still owns the business. And so we've had some experience with lithium starting batteries for motorcycles and power sports, and there were a lot of issues. And it's something we talked about on and off, and we sort of made a decision. We had a conversation and said, look, if we're going to do this, we really have to do it properly. We have to make sure that we cover the things that we know are going to go wrong, not just to make life easier for us, but so the customer always has a really good experience and the product is reliable and dependable. So we put together a list of the things that we thought the battery needed to have fundamentally. So obviously you've got to have a high quality BMS that manages the batteries, keeps the cells balanced, and will protect the battery if it gets too hot, or if it's too cold, or if the current goes too high or the voltage goes too high. It'll protect the battery and also stop it being over discharged. So some of the early lithium batteries didn't have a low voltage protection circuit in them. So if you over discharge a lithium battery, it's sort of not as forgiving as a lead acid, where you can charge it back and sort of recover it. Lithiums are not quite as forgiving in that perspective. Having said that, lithium iron phosphates are the most forgiving of all the lithium chemistries for being over discharged, but we didn't really want that to happen anyway. We wanted something where the customer could see what was going on. One of the biggest struggles, especially with the battery with some technology in it, is if it just stops working and the customer can't see what's happening and we can't see, you're sort of just flying blind because you don't know what's going on. So the whole idea was, how do we get a battery that we can communicate with and see what's going on? If it's got an issue, it can tell us that it's got an issue. So that's where the app idea came from, via Bluetooth. We also know that from our experience that one of the biggest issues with motorbikes is people don't often ride them all the time. And so the battery will go flat and they'll come to start their bike and the battery's flat. And when you want to go for a ride, you want to go for a ride. You don't want to have to sit there and wait for the battery to charge. So then we came up with the idea of a battery that we could switch on and off easily without having to actually touch the battery. So we could do that through the app. But also a battery that would hibernate. So you could set the battery up and tell it how many days to wait, so that if it sees, if you set it for 5 days, after 5 days of being inactive, the battery will go to sleep and conserve its energy. So when you wake it up, it's got the energy that it needs to start the bike and you can go for a ride. Because one of the pluses of lithium batteries is they self-discharge at a very low rate compared to lead acid. So you can leave a lithium battery on the shelf for 6 months easily and it will still have most of its charge. And then the next challenge was, so how do we wake it up? There are some other lithium batteries around that sort of have a similar concept, but you have to either touch the battery and press a button to wake it up or connect it to something to get it to wake the battery up. If you're not at home and your battery goes to sleep and you don't have the charger, or the battery's embedded inside the bike and it takes 10 minutes to pull covers off to press a button, that's really not a good solution. So that's where we came up with the idea of the shake to wake, putting a vibration sensor in the battery. So give the bike a bit of a shake, that movement will activate the battery, start your bike and ride away. So a lot of this evolved as we talked through the scenarios and what we'd sort of come across. The other challenge was when something does go wrong, or someone's having issues, it's always hard to unstitch what's happened in the past if you can't see it. So we put some really basic logging capability into the app. So if there's any BMS events like, over temperature, over current, over voltage, things like that, it actually just gives you a count, so that if there's something, customer's having a problem with the battery and we're trying to work out what it is, we can put up the log, and if something's happened 20 or 30 or 40 times, that's a pretty good indication that, okay, we maybe need to look at that because something is happening that's sort of probably shouldn't be happening very regularly. So we sort of put that in as well. So it's sort of all just evolved over time to sort of, okay, let's just tick all these boxes. What would that battery look like? And then how do we, where does it have to be competitive? It has to be a competitive product. One of the things we noticed is a lot of the lithium batteries are lowering capacity, and that's done for a reason, because, a 5 amp hour lithium is effectively the same as a 10 amp hour lead acid because you can use all of its capacity. Whereas with the lead acid, you shouldn't ever really take them below 50% capacity if you want them to last. So a 10 amp hour lead acid really has 5 amp hours usable. So that's how we get the lesser capacities in the lithiums. But what we wanted to do is just up that a little bit so that we're a bit more than 50%, just have a little bit more in the bank. So the Raptor series are all just a little bit more than 50% of what the equivalent lead acids are. And they're, more importantly, from a competitor's perspective, they're either more or the equivalent of the best of the competitors that are in the marketplace as well. So
if you could break it down to the top 3 features of the Predator Raptor battery, what would they be in your mind?
The automatic hibernation, I think, is a key feature. With that, the shake to wake, so the ease of waking it up, you can wake it up with the vibration or via the app. You can wake it up via the app.
And you said up to 6 months, or maybe even longer.
Yeah, longer. I think actually even longer. Yep.
Yeah.
And look, the ability to switch it on and off via the app. So you can actually just turn the battery off, not even worry about the hibernate. Someone can actually go, nope, just turn it off. I'm not going to ride it for 6 months. Just put the battery to sleep. And then that won't shake to wake. Once you've turned it off with the app, it won't shake to wake. It actually shut the battery down. And when you come back, you need to use the app to wake it up again.
Okay, so that, I'll make a little note on that, a little pin on that, because that's going to be one of the questions that's coming up. So the third feature would be longevity.
So 3 times the cycle life, or even longer. I think 3 times is probably conservative. And the impressive starting power. The starting power, you will hear the difference when you connect it to your bike after your AGM. It's definitely a plus feature.
And I can vouch for that. For people who don't know, I've had the prototype of this battery in my bike for a while now, and I was just thinking I should look at the cranking events, shouldn't I? While we're here,
see them with your bike.
Yeah. Can I see that from here, or will I need to be standing next to the bike?
Bluetooth has a range of about 10 meters, so you might actually see it. I can see mine when it's sort of in the shed with the shed open at home.
Just have a little. I'll just try it. Just got the app here, and it's just asked me to pull down the scan. So BAT Moto 6AH, would that be that's the battery,
one,
isn't it?
Yep. And then it'll take a second or two to connect.
Yeah, it's connecting.
Yep. Probably because of the distance, it might be a little bit slow, but it should get there.
Yep.
So if you go to the logs, touch the logs up the top.
Query.
Yep.
So how long has the battery been in my bike, do you reckon?
Oh, it's at least 6 months.
I was going to say, I reckon it has to be 6 months. So I've had over discharge is 0, overcharge 0, over current discharge 0, over current charge 0, short circuit 0, and I've started my bike 283 times.
Whoa, you've been a busy boy.
Well, it's my daily rider. So, yeah. So
that's like working. There's had no events except the starting events. Yeah, beautiful.
And like, every time I started, boom, just straight up. And I like, as you said, I have noticed a difference between this battery and the AGM in its instant start. And he did say that if it was cold or anything like that, to just power the bike on and let it sit there for 20 seconds and then hit the start button. Lithium works opposite to what my AGM. Like, I wouldn't want to do that. I'd turn it on and start it as soon as I could. Whereas with lithium, it's actually better to let it sort of warm up a little bit, isn't it? And then hit the start button, and then it'll fire straight away. Yeah.
Yep. So you load it a little bit, put a bit of a load on it, even try and start it once, and it might go rip. That's okay if it's really, really cold. Because then what happens is that load then creates some warmth with the chemical reaction. It will start to sort of permeate through the cells. So you leave the headlight on because it just keeps a little bit of a load pulling through. You wait 20 or 30 seconds. the second time you try it, it'll normally start right up. Just a little bit of warmth, and all of a sudden it'll start. There are many videos on YouTube, guys in the US at -15 and -20, like really cold.
Celsius?
Fahrenheit.
Fahrenheit, okay.
Oh, a couple of guys have it really cold.
Yep.
Maybe look, maybe it's about -20, and they, let's try this out, and they hit the first one, and it sort of does a bit of a sort of a struggling crank. They wait for 20 or 30 seconds, and it just goes boom, and it just starts, and they ride off.
Okay, fantastic.
The
one point that I wanted to say, when you said to power the battery off using the button, now that was one of the questions, was what happens to the alarm on the motorcycle if it goes into the hibernation mode versus turning the button off. So can you just run
basically the same thing? Same thing. As soon as you shut the battery down and it hibernates, it takes away all power from the bike. So the alarm will turn off unless it has its own battery, which I don't think is very common in motorbikes. However, if you let it hibernate and switch off, if in the unseasonal event that someone tries to steal your motorbike, as soon as they move it, the battery will wake up. So now there's power back to the alarm. And I know we've got a battery in a Harley Street Glide. It's one of the bikes that we've been testing with, and he's got 5 seconds to switch the ignition on with his key fob on him, so the bike will switch on. If he doesn't do that, the alarm will go off.
Yep.
Ask us how we know.
It works.
So, as soon as you move it, the battery wakes up and the alarm is powered again. Same with the GPS. So a lot of people have GPSs on their pride and joy, and sure, the battery goes to sleep because the GPS will flatten any battery really quickly. But as soon as the battery wakes up, that GPS will reacquire the satellites and it will ping, and you'll know where it is. If they put it in the back of a truck and rattle down the road, that vibration is going to keep the battery alive. So you're going to be able to track it. You're going to keep getting pings every now and then.
So really, the safest option is to use hibernation rather than power the battery off?
Yep, unless you actually want the bike to be powered off. Like we joked about last time, we've got a little brother who wants to ride your motorbike. Yeah. Switch it off with the hat. Unless he knows to switch it on with the button, he won't be able to turn the battery on. Most people, they're not going to know you've got a lithium battery that can be turned on and off in your bike. So it's highly unlikely that someone will work that out unless they pull things apart. So
before we go through the questions I got here, just a few of them. What are some of the questions you've had that people have come into R&J Batteries and that have asked you that my viewers might be interested to hear on what people are asking, the sort of questions they're asking, what's typical and what's the more unusual use cases you've had for the battery?
So I've had quite a few ask about the alarms. And so we've sort of explained to them, and we've said to them if they really want to check, they can go and simulate, disconnect their battery, and then when they connect it, for 5 seconds, because that's how Harley set it up. We've had lots of application questions. One in a racing jet ski, one in a guy that races, I think, a 25 horsepower outboard racing boat. Let's put a Raptor in. We've got a couple that have already gone into racing cars. So one of our customers has got a 3 Series BMW currently, or has been running a HC20 AGM battery, and he took that out and put in the Raptor because his ability to turn the car on and off. So he said, as soon as I've finished racing for the day, the ability to just turn the battery off, and then we winch the car off with the trailer. I don't need to worry about the battery going flat, etc., etc. That was a real plus for him. He wasn't so excited about the shake to wake, obviously.
Yeah.
But
that's the thing. It's not just for motorcycles. It's for cars. You have batteries for cars, watercraft, powercraft, power sports, and even I think you even said an airplane. Someone was asking about an airplane that would work in an airplane.
Got a customer who's bought one to put in an ultralight where, again, he was using an AGM battery. He wanted to save a couple of kilos. We went through how his charging system was working. He did some checks. It was right on, I think 14.2 volts. So it's right where it needed to be. So, I just said to him, look, do some ground tests because it's an aeroplane. But, and the logs will obviously help him as well as the live data on the screen and his app. But there were no issues. He checked it and there were no issues. It went perfectly. There are lots of people who have, race cars and track cars that are using motorbike batteries anyway today, like especially the 20 and the 30 amp hour size, the two larger ones. They're actually quite common in lots of racing cars. So these batteries are designed to be a drop-in replacement for those sizes. So it's sort of a pretty easy thing to do. And
you don't need a special charger. You can use your trickle charger to charge them.
Yep. So the charge voltage range 14.4 to 14.2 to 14.6 is sort of the nominal range, but lithium iron phosphate's pretty forgiving. So we've done quite a bit of testing with lithium iron phosphate over the last 5 years because we also have a lot of deep cycle lithium iron phosphate batteries. 14 volts to 14.6, anything in that range will work fine. As soon as you get below 14, you start to struggle to get the battery to 100% state of charge. But even 14 volts will get the battery to 100% state of charge.
And your average trickle charger can handle that no problems. Like would do 14.3 or something. Was that what?
14.3, 14.4 normally. That's a nice middle ground for AGM and flooded batteries in that 0.3 to 0.4 range. Yeah, and then once it's charged, and you've got it in the bike, and it's sort of right like you've seen. You've never had to yours.
No,
it just works.
Yeah. Well, I've got my AGM on the trickle charger. It's keeping that alive. But this is totally fine. I don't have to worry about the Predator Raptor at all. So
one day you'll get brave enough and you'll take your AGM off the trickle charger because you realise you don't need it anymore.
Yeah. Well, I don't want it to sort of die. You know what I mean? So I thought I'll keep it alive just in case. But yeah, it'll probably die even on the trickle charger before this Predator Raptor battery gives out the ghost, I reckon. Yeah,
it will. Because this long-term testing, like we've got one in your bike, is highly valuable. That accelerated testing where you're always looking for an early warning. It doesn't matter how much homework you do with a brand new product, and this is a world first. It sounds a bit corny, but it's actually a world first. We had it challenged by one of the advertising sort of standards companies, who said, you're saying it's world first, can you justify it? And we went through all of the features and demonstrated that none of these features exist in power sport batteries today. And I went, no, you're right, it's a world first.
Some of the comments says, oh, this is nothing new, blah, 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 blah. And I said, well, it is.
Well, it is.
It is new. Yeah. You haven't seen this before.
There are batteries with some of the features, but there are no batteries with all the features, let alone all together, because we really tried to, I guess, deliver a product that's flexible enough. You can use all of the smart stuff and the hibernation and the shake to wake, or you can put it into what we call normal mode, where it's just a battery. It doesn't do anything smart. You can still turn it on and off with the app, but it just sits there and it just bees a battery.
Well, I've started mine 283 times. That's the second time I've looked at the app. There's no reason to it. Just ride. And I forget it's even in there. I just ride and go, And
that's what we expect. Once you've set it up, and it's working, nothing goes wrong, you'll never look at it again. But to have the ability, if something does go a bit funny or something's not quite right, you can have a look and see if it's a battery, or if the battery says it's working fine, then you've got to check something else. But it just speeds up diagnostics if there is ever an issue as well.
Yeah. And what is the warranty on the battery? Just
2 years.
2 years. Okay. Yep. All right. Okay. What I might do is I might head over to the questions.
Sure.
Sparky as 2 says, that is a cool battery. That would be great if GPS was integrated. Since it uses Bluetooth to turn on and off, you'd think that it would have a parasitic drain.
Yes, it would be a great idea if we had GPS in the battery, but GPSs use lots of power. They're actually pretty power hungry. So that's what prevents that. Otherwise, we would love to do it. That'd be great. Whereas the Bluetooth was always designed as a low power circuit or device. One of the charters, if you go and have a look at the original thing with Bluetooth, was it has to be a low power, high efficiency communication protocol. So the power with Bluetooth can be modulated so that it doesn't use excessive amounts of power.
When the battery's hibernating, is the Bluetooth on or off?
It's still on. So it's still
on.
able to communicate with it. But it goes into like a low power standby mode.
Okay. And so you can get your six months on the shelf, no problems, even with that all running.
Yep. But any time you go up to the battery, and we've done it with a number of batteries because we're still playing with them a lot. You go up to any battery, it's hibernating, pull it up on the screen, connect to it, and you can see the status, and you can see the power is on, so the blue bar, power on, but your discharge and charge boxes are both red, so that's how we know that it's hibernating.
Yeah. Okay. Yep. Chris Hart says a fully charged lead acid works fine down to minus 50 degrees Celsius. Lithium is fine as long as the temperature is above 0 degrees Celsius. Is that right?
No, it's not. So batteries are like humans, okay? They're an organic being, and the colder they get, the slower they get. Minus 50 degrees for a lead acid is a huge struggle, and unless it's fully charged, it will blow up like an egg, because when when a lead acid battery discharges or is not 100% state of charge, what happens is the sulfuric acid moves from the solution into the plates, and what's left behind is water, and water freezes at zero.
Okay.
So as you get further and further below zero, the battery wants to freeze, and unless the battery is really high state of charge, it will actually start to freeze.
Okay.
If you've got a cold battery, like a really cold battery, you need to warm it up to get it to work for a lead acid. Lithium is the same. So the discharge characteristics of lithium, they'll go down to -20, -25 quite happily.
Celsius.
Yep, Celsius, and you can warm them up and they'll deliver more and more current the warmer they get.
Yep.
It's the charging that you can't do with a lithium below zero. So when a lithium battery is below zero, you can't charge it because the electrolyte becomes semi-crystallized.
Yep.
The BMS in our battery prevents that. So you put a battery in the freezer, and we've done it just to check. Put a battery in a freezer, you'll see that the discharge will stay green, but the charge will go red, which is saying you can discharge me, but you can't charge me till you warm me up.
Yeah, okay. Yeah. Yep. So it's got protection for that built into it. Yeah. Yep.
And I guess that's just as a practical comment. In Australia, I'm not aware of anywhere in Australia it gets to -50. You know, up in the mountains, we get to maybe -20 or something. But there's too many motorbikes up.
Matthew Rafferty says lithium bike batteries are nothing new, and you will be able to buy one locally. Most are made in China, just like the R&J one probably is. I think we've already established that this is not your standard lithium-ion battery. I'll let you take it there.
Look, just like with lead acid, there are different types of lead acid batteries. There are starting batteries and there are deep cycle batteries, and they're actually made different. The construction is different, and there are little tweaks that you can make both chemically and physically to make them either better at starting or better at deep cycling. So for lithium batteries as well, they are not all the same. Some are designed with deep cycling in mind, and some are designed with more of a high burst starting current in mind. And so obviously the cells used in Raptor are designed for starting duties, and sure, they can deliver power and cycle, and they're still, very good at cycling compared to a lead acid, but their sort of strength or their big flag is, the starting power is what they're designed for. Good question though.
Yeah. And it's just like, it's good to field all these and see how it goes.
And they do, you're right, he is right, they do come out of China. So that used to be a negative thing. We've all grown up in, Chinese products. China are able to make things to a price just like Japan was in the 70s. Japanese toys used to not be very highly regarded because people, in the West used them as a low-cost manufacturing base, and that's where China was. But that's not where China is now. They can make cheap stuff if someone wants them to make cheap stuff, but they've clearly demonstrated they can make quality stuff because we have iPhones and Galaxy phones that are made in China. And you look at vehicles like, I'll just pick a brand, BYD. China can make premium quality products if they're given the charter and the ability to show what they can do. They are absolutely capable of making quality products.
Yeah, fantastic. Yeah.
And they're just as proud of it as we are, having dealt with the manufacturer at a very personal level. They take just as much pride as we do when we do something that's really exciting.
Yeah, cool. Chris Hart also asks, will the clock lose the correct time every time the battery goes into hibernation?
Yes, it will, unless you've got a GPS clock, which there's not many motorbikes that have GPS clocks. But yeah, that's the one thing. One of my bikes, because I don't ride it as much, every time I wake it up, I've just got to set the clock. You get pretty quick at it if you want it to work. I'm a bit OCD, so I want the clock to be the right time. But we've had those had customers and had conversations with them, and some of them go, I don't really look at the clock anyway. My phone and my watch has got the time. They don't fuss about it so much.
Yep. And in my case, I've never had to reset the clock because I don't think my bike's ever hibernated. I'm just riding it within the 5 days. Yeah, within the 5 days, I'm definitely riding it, more than every 5 days. So it's only going to be an issue if it goes into hibernation. And if you park up your bike for a couple of months and then ride it again, setting the clock's not a big deal, really, when you think about it. Like, for the benefit you're getting of not having to worry about tenders and just let it sit there and just the convenience of having it ready to go when you're ready to go, I think it's well worth it.
Yep. Well, normally if you don't ride a bike all the time, I know I do, when I do start it up, I always let it warm up for a couple of minutes before I ride it.
Yep.
Just get the oil circulating. So that's when I set the clock while it's warming up. So.
Yep. And And on my bike in particular, the clock's really small, and I never use it because it's sort of a bit hard for me to read. So I think it's at the right time. I don't know. I don't. You know, I did look at it the other day. It is at the right time, but it's so small that it's just something I don't look at. I don't. It's not. Yeah, I have much higher priorities than the time when I'm riding. Jeremy Stagg. Yeah. Jeremy Stagg says, I'm hoping R&J can patent this and Ballarat can benefit from this with jobs. So what's the situation there? Is that it's something that you have patented, or is it?
So we developed it in partnership with one of our manufacturers, and although a lot of the ideas were our ideas, because they, I guess we had the ideas and they actually made it happen. So they have actually put patents on it, but
okay,
patents can get a bit grey, unless you want to go to court a lot. But they've actually applied for patents in a number of countries around the world where they plan to sell it. So we have exclusivity because we developed it with them and came up with the whole concept. They said, look, we'll give you exclusivity for 12 months. So that, as a recognition of this was a partnership. But obviously they're in business to also sell batteries and make money, and it would be unreasonable for us to expect that they wouldn't sort of be able to sell it to other countries and other customers. So that's sort of where we are. Eventually you'll probably see this with other brands. That's just the world we live in.
Yeah. I did actually speak to a patent attorney years ago about a product I was developing, and he said the patent was only as good as the money you have to defend it. And I thought, okay, so if you got lots of dollars to back it up, and fight it, then yeah. Okay, now here's a question from Paul Adrian. What about the elephant in the room, the charging voltage? These batteries usually need a higher voltage, something like 14.6 to 14.8 volts to fully charge than normal batteries, say 13.8 to 14.2. With the bike's normal onboard chargers, the battery only gets partially charged at best. Is that true?
Yeah. No.
Okay.
So I can talk charge voltages and put you to sleep with it. So normally, look, I can rattle the ranges off. So, an AGM battery, the ideal charge range for an AGM battery is 14.1 to 14.4 volts. And for a flooded battery, so like a calcium battery, your flood batteries where you have the acid pack and they've got the liquid swishing inside them, they're 14.4 to 14.7. Lithium iron phosphate are nominally sort of 14.4 plus or minus 0.2, so 14.2 to 14.6. We've tested them down to sort of 13.9. At 13.9, they'll still charge and almost get to 100%. As soon as you hit the 14.0 volts, they'll actually get to 100% state of charge. So as I said, they're pretty forgiving, anywhere between 14 and 14.6. You probably even get away with 14.7. I've never seen a charging system running at 14.7. No one sort of runs at that high because you don't need to. If you did go too high, if it really got up to, I think, about 15 volts, then the BMS will cut in and actually disconnect the battery. So it'll take a fair bit of abuse before it will sort of shut it or protect itself. Normally, it's the bigger problem is bikes with a low charge voltage, and one of the beauties of Raptor is you can put the Raptor in a bike, start the bike, hold the revs up because it needs to be up above idle for the charging system to work properly. And you can actually monitor and see what charge current and what voltage sort of your system is running at. We currently have a battery that's being reviewed. I think there's going to be a couple of articles in a magazine. I can't give it all away yet, but in a early 1970s Japanese bike. Just going to see exactly how that goes. I don't have any problem at all.
Your average motorcycle alternator, what's it typically put out voltage-wise for charging?
Yeah, look, 14.1 to 14.3 is normally what we'll see. The modern bikes are a little bit higher, maybe 14.4. Like everything, as time goes by, charging systems have got more reliable and more durable. Some motorbikes, including some of the modern motorbikes, especially the smaller capacity engines, will actually turn off the charging system until the engine is off idle, so it's actually revving.
I've always understood that, that you have the engine has to be up above a certain amount of revs before it's going to start charging the battery. And I've always found it amusing people sitting there just idling their bike, thinking it's charging the battery, but
and cars are the same.
Cars exactly. That's where I learnt it in cars. Yeah.
If you actually had it spinning fast enough to be charging properly at idle, you would actually end up over revving it at maximum RPM. That's sort of why, where it spends most of the times up idle. But we've got one in a sort of a late model Honda little trail bike, a kid's trail bike, and you can actually see that actually switches, deliberately disconnects the charging system until it's off idle. So
Yeah, okay.
it's not uncommon. The smaller engines will actually idle really rough if the charging system is trying to run. When it's a small capacity engine, they will sort of struggle and it will sort of disrupt their idle a bit.
Yeah. Peter Koning says, I need one. I only ride once or twice a month and batteries are a problem for me. When and where are these available? So we know they're available now, but where are they available?
They are available at any R&J Batteries store in Australia and New Zealand. We have 5 stores in New Zealand and 24 stores in Australia. And then we also have a network of resellers. So we have other companies that also sell our products as well. So you could ring up any sort of reputable battery seller, independent, and they may actually have our products. Or you can ring one of our stores.
Still Australia, New Zealand. Yep. Is there any plan to take it overseas?
Not directly at this stage. We actually have a company who we have sort of associations with, and we sort of have partnered in things in the past. And so we're sort of talking to them, and they're only just started selling motorbike batteries in their market. And so I think we're going to send them a couple of samples, and they're going to sort of test, and they're just dipping their toe in the water in the motorbike and power sport world.
Yeah, okay, cool. Now, John Goodman asks, will it work okay if the bike has a tracker? What are we talking about, a tracker? Is it like a GPS? Yeah, okay.
Tracker.
Yep.
So the GPS trackers actually use a lot of power. Anyone that has a GPS tracker will know, because if they're not using a trickle charger, the battery will go flat pretty quick. While lithium doesn't like to be trickle charged, lithium iron phosphate will actually tolerate that. It's actually a really tolerant chemistry. So if you had a tracker and you wanted to have a Raptor and you plug in a trickle charger when you're not using it, the Raptor would tolerate that. Yeah.
But if you had it in hibernation mode, wouldn't the tracker turn on once the bike woke up, like once you started moving the bike?
Well, you'd want to turn the whole hibernation function off if you were trickle charging it, because otherwise the battery will disconnect and then the trickle charger will stop seeing that there's a battery there and stop delivering power. So you'd put it into normal mode so that it just acts like a normal battery, and then you top it up. And what would really happen would be the trickle charger would be powering the GPS tracker. There would be almost no power going into the battery. It would all be sort of going to the...
Yeah, okay. Would you need to have that constantly powered if the tracker gets woken up with the battery in hibernation mode? Say if the tracker goes to sleep and the battery's in hibernation, and then you shake the bike like the alarm, would the tracker then turn on? And then, if the bike's stationary, you don't need to track it. You only need to track if it starts moving off away from it. That's my thinking. So
that's what I would do.
I
understand that some people may want to have the tracker powered up all the time, and I understand why.
Yeah.
So the battery has the flexibility that would let you do that. There's some research. I've read a number of white papers. The white papers that's just code for long, boring document from the university.
Yeah.
I've read a couple of white papers on lithium iron phosphate chemistry and other lithium chemistries, and they say that constant trickle charging accelerates the aging of the cathode, but they don't put a number on it. So while technically it's true, I could never ever find any definition that said it will shorten the life of the battery by X. We've had a number of deep cycle batteries that customers have bought and have trickle charged them, and they're still in the field and working perfectly. So I don't believe it's significant, but I can't put a number on it.
Trevor says it's just a Bluetooth BMS 4-cell LiFePO 4 battery. They've been about for a decade. But it's not that, is it? It's just more to it than...
I'd like someone to show me another power sport battery that has Bluetooth.
Yeah. Okay.
There are plenty we have our deep cycle batteries all have Bluetooth in them, absolutely. I haven't seen a power sport battery that has the app and the Bluetooth communication.
Okay. Jonathan L says, shake to wait. I've heard that name before somewhere. I think he's sponsored by Red Bull. He spelt shake, SHEIKH, shake. You're going to get those. That's a good one. I like
this. Shake and bake. So for a little while, when we were developing the battery, one of the guys that works with it, he would say, "Oh, the shake and bake battery," because there's a product you go with the shake and bake.
Yeah. Okay. Was there any testing with the 2024 Harley Davidsons? Lithium ion had failed during an influencer's review. Apparently, the new IFCU doesn't tolerate it. You heard anything about that?
No, I think in all the experience I've got, with lithium battery, I've got a lithium battery in my car, even a prototype. It's just a battery. I think we overthink it sometimes. It's just a power, an energy storage device that can accept and deliver power. The vehicle doesn't know that it's lithium. All the vehicle knows is that I can get power when I need it, and I can put some in it if there's some capacity for it. I don't know what it wouldn't tolerate. Lithium batteries are actually better for modern vehicles because when they're under load, when they're cranking, for example, we did some tests on a 1500cc V-twin cruiser bike and got a high-speed logger on it. And under cranking load, the lithium held almost exactly 1 volt higher than the AGM did. And they were both fully charged, both new batteries. What that translates into, when you're cranking a bike, you've got all these control modules. They actually like higher voltages. They don't like the voltage dipping too deep. So a lithium battery is actually more likely to keep a modern vehicle happy because even under cranking, it's holding a higher voltage, which means that everything can sort of stay awake and operate more efficiently. So I'm not sure what it's about.
Well, see, the thing is, like with a statement like that, we don't know what the quality of the lithium ion battery that reviewer was using, or what the chemistry was, or so it's sort of
other accessories were fitted.
How
was the battery charged or was it not charged? You put a flat battery in, the voltage will drop when you crank, for example.
And when you're saying that it holds a higher level of voltage, 1 volt is a lot, isn't it? In terms of, it doesn't sound like a lot, but in terms of these sort of batteries, 1 volt is a big difference.
So if you think a motorbike, say a motorbike's pulling 200, it's a big bike, it's pulling 250 amps. Power is voltage times current. So 1 volt and 250 amps is 250 watts. That's a quarter of a kilowatt. It's a lot of power.
Yeah, for sure. Yeah.
That's up pretty quick.
Someone says here, Dav8388 says, he said it, this is referring to the video that we made. He said it was only available in Australia and New Zealand stores, but could I order it from an Australian store and ship it to the US? This would be great for storing my bikes in the Wyoming winters.
Lithium is difficult to ship.
Okay.
So lithium iron phosphate is different to all your other lithiums, but the courier and shipping organisations haven't quite caught up with that yet. I know there's a whole lot of work going on in the background with, the Australian Battery Industry Association, I believe, are working on it, as well as the sort of international, I think IATA it is, the shipping and transport bodies to, I think, work out how they can categorise lithium so that, for example, lithium iron phosphate, which is incredibly stable and can be shipped quite safely, is not treated the same as, for example, the nickel, manganese, cobalt style lithiums, which are the ones that catch fire all the time and appear in the press. And, on plane tarmacs, for example, when there was all those mobile phone batteries that caught fire, they weren't lithium iron phosphate because lithium iron phosphate's not combustible. They're the nickel, manganese, cobalt. And so I think the transportation industry is working on becoming a bit more granular to be able to understand that there's a couple of lithiums that aren't like the reactive ones and they can actually be shipped quite safely.
Yeah,
we're not there yet.
Yeah. But so it's more a regulations thing rather than an actual product safety.
Okay.
So he
could ship it, but he might just get charged a premium to ship.
Yeah, okay. Yeah. RP Smith writes, an alternator designed to charge a lead acid battery is not suitable to charge this type of battery. Also, what happens to your alternator and electrical system when the engine is running and the battery's BMS disconnects because of an over voltage condition?
As we talked about, if you've got an over voltage condition up around 15 volts, there's something wrong with the charging system. So maybe that's going to save you from something worse happening. But having said that, once the bike is running and revving, the battery doesn't really do anything. It's like a car. Once a car's running, you can actually disconnect the battery and the alternator actually runs the car. It's not the battery. The battery is there for starting and storage. So although you wouldn't recommend it, and what you would find is if you disconnected the battery while the bike was running, you wouldn't have a problem until you let it go back to idle, because then the charging system loses its power output and then the bike would probably stall.
Yeah.
So
Yeah.
if you had a bike that was, for example, stalling, and we actually had this in the testing. So one of the bikes that we tested one of the early prototypes on was a modern Japanese bike, and it started fine, everything was fine, and he rode it away and it kept stalling at the traffic lights. And we worked out that the battery was going into a specific, like a shipping mode that was embedded into the BMS chip. And we never worked out exactly why, but the engineers suggested it would be something to do with maybe the switching frequency of the rectifier or something in the bike. Anyway, they were able to duplicate it at the factory. They've got exactly the same bike, put the battery in, were able to log it and work out exactly what was happening with the BMS. And so then they modified the code and actually deleted that whole function in the firmware. And so we had it covered. And I've seen a couple of other lithium batteries having a similar problem, and I suspect that's what's happened is there's this mode that it's sort of activating. He could tell because every time he let the bike idle, it would either almost stall or stall because the battery was protecting itself because it was seeing something that it didn't like.
That statement, an alternator designed to charge a lead acid battery is not suitable to charge this type of battery. Is that correct?
No, it's not true.
Yeah, okay.
An alternator or a charging system just makes a voltage. And as we've sort of talked about, the low to mid 14s is where they're all targeted, and that works for lithium, flooded lead acid, AGM, even motorbikes with gel batteries. They're all in that low to mid 14 volt range.
Yeah. Okay.
Like I said, we can overthink this sometimes because we know that the chemistry is different in the cells. You start to think it's all different, but it's just a battery. It's just an energy storage device. It just uses a different chemical reaction.
Yeah, and that's the thing. Like, but at the same time, because it is all new, people are going to have these questions, and and it's like when you have a little bit of knowledge about something, you sort of tend to think you understand how it all works, but that you sometimes you only have part of the picture, and so it's people ask the questions, and this is what this is all about, to let people know exactly how it all works.
I've been there when I first started playing with lithium. You start follow the rabbit down the hole, and you think about it too deeply, and you got to remind yourself and pull it back and go, let's just go back to basics. When everything's working normally, the BMS is basically invisible. So how the BMS works is the negative is connected to one side of the BMS and the other side goes to the negative terminal, and the positive goes from the battery straight to the positive terminal. So the power has to travel across the BMS to get to the negative post so you can deliver power. So when everything's good and the BMS is happy, it's basically invisible because the MOSFETs, which are basically an electronic switching device that can go between high resistance and low resistance, they just sit there in low resistance and it doesn't interfere, it does nothing, and the battery just works.
Just passes through.
Yeah. It's only when something goes wrong and it says, no, I'm going to protect the battery because your voltage is too high or you're pulling too much current from me or something, that it sort of interferes. But the rest of the time, it's almost passive, except for there's a balancing circuit that monitors each of the 4 cells and just keeps them all balanced. And you can see that in the app, the 4 cells. So there's maybe a little bit of activity there if the cells get out of balance, which is a natural thing that happens.
But which is also important to keep them balanced, isn't it? For longevity. Yeah.
Longevity and battery performance. So each cell is running at the same level, so you get a better overall sort of current and voltage flow. But when everything's working normally, the BMS basically doesn't interfere. It's invisible to the whole process.
Yeah. All right, cool. Chris Hart also says, I've got loads of things with lithium batteries and it's great, but unless it's as reliable as AGM, I'm not paying a huge premium.
Yeah, I guess maybe he's not the target customer that we're that's looking for this product. So we've had lots of discussions about price, and the purchase price is expensive. We're not going to make out it's not. It's 2.5 times the price of a AGM. It's going to last 3 times as long or more. But what we've found already is that when someone comes in to have a look at a Raptor or ask about Raptor, they've normally done some research, and so they know that the lithium batteries are more expensive. We really haven't had any conversations on price, except we had 2 customers who told us they're too cheap, that we could sell them for more. They said, with all these features compared to the other 2 brands, I went to the brands, but the 2 other brands he'd looked at, he said, bang for buck, your battery's better. You could charge another $30 or $50 a battery.
Yeah.
I think,
and that's the thing, isn't it? Like, it's horses for courses. If you have use of those features, well, they're worth something to you. if you don't need them, well, they're not worth. You know what I mean? It's yeah, I get it. But having said that, a battery that lasts 3 times as long as what I'm used to in motorcycle batteries, as well as that extra cranking power, those 2 features alone, with even without the hibernation, they're worth to me, they're worth money for sure.
Yeah.
One last question, one last statement, I suppose. Slug Racing says, this guy doesn't ride. None of my bike's headlights turn on before they start. Therefore, I can't wake them up. But isn't that law that the headlight has to come on, or does he live in a country where that's not a law, that they don't have to turn on?
Yeah, maybe. Headlights, hardwired headlights have been around for an awful long time.
Yeah,
I've got one of my oldest bike is a 1996 BMW R1100 RT,
and
the headlight comes on all the time.
And ever since I've been riding, since the 80s, I'm sure every bike, that was law back then, that as soon as you turn a bike on, the light's on. That's just law, unless it's some countries where that's not the case. Yeah. But then why would a manufacturer? Most countries that'd be the case, I'd say now. Why would a manufacturer just have that turned off for a certain country? Surely they just ship them all the same. Well, I would imagine. Yeah.
And if it's a bike from the 70s, and in the 70s it wasn't law, you have a switch and you just would go on, and then your headlights off.
Yeah,
so you can turn on yourself.
Yeah. Sorry to finish on a negative one, but
that's not negative. I guess it's a question that if one person's got a question, then there's someone else that's thinking a similar thing. Or
But it's you're going to get your good with your bad. But most of the stuff's been positive, and people get it. You're going to get your naysayers in everything and anything. But no, I think the longer it's in my bike, the more I appreciate it, and I probably won't appreciate it until 5 years' time when it's still going strong and still doing what it's supposed to do. Whereas
and we're still talking about it.
Yeah, and my typical battery would have been, I've probably replaced it by then. My typical AGM, I'd say. And just for people who don't know, that bike in the background behind you is an R18, and Tim actually rides an R18, so that's why he's a bit of a fanboy there.
I do ride bikes. And if you go, we've got a website, predatorraptor.com. There's a whole lot of information on that site of all the features, the 5 batteries in the range currently. There's a video of me going through all the features if you want to get a bit more detail on all the features. R&J Batteries also have a YouTube channel. On that YouTube channel, we have a couple of videos. We made sort of a TV commercial for the battery, so that on websites and sort of little snippets that pop up, we have some collateral where we can sort of show something, tell a bit of a story. So I had a little bit of fun with it. It's actually my son who's in the video, because
I think I've seen that.
Like a good thing.
I think I've seen that.
we're joking. So in the video, if you go and watch the ad, we sort of had a bit of a laugh with it. And we went, everyone goes, I like the bit, the click click vroom, and you was in the ad, you'll see what click click vroom is. But because it just sounds really good. They recorded the bike and they edited it in. It sounds really good. But if there's any questions, if you have a look at the website and someone's got questions, they can contact me. They ring any R&J Batteries branch and they'll give them the details. They can get the details to me, and I'll give them a call if they've got questions or want to have a chat about it. I'm more than open if someone's got some genuine questions to have a discussion on it.
And that's been my experience of interacting with you. Is like you're not hiding anything. If I have any questions, this is what it is. This is the pros, this is the cons, and it is what it is.
Yep, we had some issues when we developed the battery. That's why we tested it.
Yeah. Well, thank you very much for your time today, Tim. I think this Q&A session's been it's been great for 2 reasons. One, I've learned how to set up my system because we had issues trying to get all this going.
Oh, well done. You worked it out.
Yeah, so we got there. So thanks to your help as well. We start off with Teams, and that was a complete fail. So now we're on Skype, and that seems to be working well. So thank you for this. So there you go. That was great for me to be able to set this up so I can interview other people, which I'd like to do down the track. And also then, the Q&A because you get all those questions in the comments, and you don't have time to go there and filter through and answer them all and things. And I think this is a good way just for people to hear from the horse's mouth, if you like, exactly how it works and what you can expect. Absolutely. So thanks for your time.
Thank you very much. Thanks for your testing.
Yeah, no worries. Well, thanks for the battery.
keep on cranking. Yeah,
Yeah,
see
we'll
how many
do.
pieces
Yeah.
get to 1,000. Yeah,
Yeah. Oh, that shouldn't be too long, I reckon. Yeah.
I reckon you're right. No, it's
Uh,
been really great.
Thanks, Tim. Thanks for watching, everybody. And until next time, bye for now. Thanks, Tim.
No worries, it was good.
Yeah. It's always good to catch up.